Greetings everyone. I am Rishil Kumar from Group 475 and today I am here to present our project titled FinBloom, a real-time financial intelligence for large language models without manual retraining. The central aim of FinBloom is to address a critical limitation in today's AI models, their inability to access real-time financial information. Our project focuses on bridging this gap by integrating live financial data with large language models to enable continuous, accurate, and transparent financial analysis. The problem identified in the base research paper is that large language models lack real time knowledge. Their outputs quickly become outdated, and frequent fine tuning is both costly and opaque, meaning we cannot clearly interpret what the model has learned. Furthermore, RAG techniques, though promising, often fail to handle structured tabular financial data, high velocity market systems, and domain specific financial queries with accuracy. In financial contexts, this poses serious challenges. Analysts, traders, and decision makers depend on timely and reliable information. Any delay in accuracy can lead to financial losses, regulatory non-compliance, and missed opportunities. To address these challenges, the base paper highlights a clear business need for real-time intelligence system. Our solution, FinBloom, is designed to meet this need through three primary objectives. Real-time market intelligence, providing up-to-the-minute financial metrics, stock trends, and news in a unified interface. Compliance and audit support, generating source-linked verifiable responses suitable for regulation-heavy financial environments. Decision support and research, assisting investors, analysts, and educators in deriving grounded insights for strategy and learning. The primary beneficiaries of this solution include financial analysts, traders, compliance systems, and financial students, all of whom require accurate, auditable, and transparent financial data. And this is our architecture diagram where user inputs his prompt, also called as user query, at the chat interface. From there, the chat user query is sent to the agent, where agent converts the user query into data request. For example, it will generate a query to fetch data from the data module. It can, depending on the user query, it can fetch data from either structured data or unstructured data. The fetched data is again provided to the agent and it will optimize the user query along with the data which has been fetched from the data module. This optimized query is then sent to LLM, which will generate the financial answer for the user query. This answer is sent to the chat interface where user can see it and he can continue the chat along with the model as well. During milestone 2, we have made significant progress in realizing the FinBloom system. Firstly, we have built a data module capable of handling both structured financial data such as stock price and volume and unstructured data such as market news and sentiment reports. Secondly, we developed comprehensive documentation. Also, we successfully created a working deployed version of FinBloom that demonstrates the end-to-end functionality of our system. Instead of relying on a single fine-tuned model, we developed a multi-agent architecture where multiple LLMs collaborate to produce more accurate and contextually rich outputs. Finally, we made the project publicly available on GitHub along with complete instructions for replication and deployment, ensuring transparency and open access for further research. The final tech stack is here where we are using TypeScript and CSS for front-end. For backend, we'll be using TensorFlow PEFT. And for data module creation, we are using PostgreSQL for storing the structured tabular data. And for unstructured news data, we are using Elasticsearch. We are using FinHub API for fetching the unstructured day-to-day data like news articles and other reports. For intraday stock data, we are using BSC Python module. It is a Python SDK by using which we can get real-time financial data of Bombay Stock Exchange market. For historical data, we are using Yahoo Finance Python SDK by using which we can fetch data. And for knowledge grounding, we are using Gemini API, which we haven't mentioned here, but we are using Gemini API as a knowledge grounded model, which has been trained and its weights are frozen till year 2023. Yahoo model can fetch data from 2024 till present date. Hence, these are the API features we are using for creation of data module. In conclusion, FinBloom represents an important step toward enabling real-time knowledge grounding model in the financial domain. Our work demonstrates that by integrating continuous data streams and multi-agent intelligence, we can eliminate the need for frequent manual retraining, reduce operational costs, and enhance the explainability of AI systems. We envision FinBloom as a foundation for future financial AI systems that are not only intelligent but also auditable, adaptive, and dependable in real-world decision-making environments. Thank you. This is my front end, where suppose any user is didn't register previously, he can go to create account and he can use his credentials or he can directly log in with Google. Once he has registered, he will be redirected to sign in page where we need to re-enter our credentials and log in. So this is our financial dashboard where we can have the portfolio values, the watch list if he decides to or see some stock data as on his primary dashboard. These are the latest financial newses which can keep the user up to date on the data. This is our chat interface where user can interact directly with the agent and he can get whatever he want to ask. For example, summarize the last earnings call for Tesla. This data is sent to the agent. Agent will fetch the data from data module. A data module will give the data. Once the data is fetched, original user query and the fetched data are given to LLM, which will generate the final output. This is our final output, which you can see here. And we can continue our chat asking more about it as well. Whatever chat we are doing here will be saved in history as well. This is the profile where user can edit his profile, password, etc. Settings. You need to provide manually your Gemini API key. This is the about page. We can even toggle the brightness between as well. This is our data module where we have two folders, structured and unstructured data. Unstructured data contains news articles which are fetched from FinHub API. Structured data runs 24 by 7 where we are using two fetchers, BSC fetcher and Yahoo fetcher. So, for every 5 minutes, intraday data of all the companies in BSA are fetched and stored Likewise, historical data is fetched for every 1 hour. We can even manually change it to 12 hours, 1 day, and so on, and save them on our system. Let me show you some demo of what type of data and how the data is stored in .csv formats. This is the intraday data of a company named ABB India Limited, where its BSC symbol is this. The time at which it fetched the data is present here, and high low HLCV data of this company is provided in intraday, whereas for historical data of the same company is this, where data is fetched from 6th November 2024 to current. Even it stores OHLCV data as well. Thank you.